Example problem 3, using a geometric sequence. This is a physics problem. When a ball bounces, the heights of consecutive bounces form a geometric sequence. What are the heights of the fourth and fifth bounces? One of the things we should consider right away is that in this problem, we know the height of what looks to be the first bounce is 100. We don't know the height of the second bounce. I'll insert a blank there. We do know the height of the third bounce, and I'm leaving out units for now for simplicity's sake. We don't know the height of the fourth bounce, nor the height of the fifth bounce. And I've inserted these extra spaces because I recognize that the problem is asking for the heights of the fourth and fifth bounces. So we know the first term, we know the third term, and we're told that this is a geometric sequence. So we'll use what we know about geometric sequences and the explicit formula for a geometric sequence. That any term a sub n equals the initial value a sub 1 times our common ratio raised to the power of n minus 1. We know the third term's value. That's going to be helpful. So we'll consider our third term, a sub 3. By the formula, we know that will equal our first term, we can call that a sub 1, times our common ratio. That's unknown to us at this point. But our common ratio raised to the power of n minus 1. And in this example, n is 3. Our third term is 49, so n is 3. 3 minus 1, of course, 2. Now to solve. We'll begin, well, we're down to it's really a basic SADMAP problem, inverse of the order of operations. So we'll divide both sides by 100. Move to the left where I have some more room to work. 49 over 100 equals, a little bit of cancellation on the right-hand side, equals r squared. Now we apply the square root to both sides of our equation. And of course, our squared and square root are inverse operations, so they will cancel, meaning this entire problem shifts to the right and becomes the square root of 49 over 100. Recall that can be written as the square root of 49 over the square root of 100. And the square root of 49, or at least the principal square root of 49, is 7, and the principal square root of 100 is 10, so this becomes 7 over 10 equals, our squared and square root cancel out, r. So our common ratio is 7/10. One more thing to consider. So we know there are two square roots of 49, positive 7 and negative 7. But in the context of this problem, negative 7 doesn't make any sense. We're only going to be talking about bounces as having positive heights. Same thing with the square root of 100. Positive 10 and negative 10 are both options for us, but negative 10 makes no sense in the context of the problem. So we have our common ratio now, 7/10. We can use that to find each of our terms. Perhaps one of the simplest ways is to actually build the sequence. 100 times 7/10 most likely simplest for everyone if we think 100 as being 100 over 1. Cross reduce, 10 divided by 10, I'm sorry, 100 divided by 10 is 10, and now 10 divided by 10 is 1. 10 times 7 over 1 times 1, 70. Therefore, the height of our second bounce, 70 centimeters. Now, it'd be worth double checking. Let me check out the book's work over here. 7/10. After 70, when we multiply 70 by 7/10, do we arrive at 49? 70 times 7 over 10. Let's think of 70 as being This is looking good. 70 is being 70 over 1. Cross reduce. 1 and 7. 7 times 7, sure enough, is 49. So to find the next two terms in the sequence, we will simply multiply 49 by 7/10. And 49 thought of as 49 over 1. 49 times 7. In my head, I'm thinking of that distributive property trick that we've talked about. 7 times 50 would be 350. But 49 is 1 less than 50. So I'd be subtracting that 1 7 times. So I'm thinking 350 minus 7. 350 minus 7, 343 over 10. Well, and this is a fine answer. This can represent the height of our fourth bounce as a fraction, but perhaps it seems more reasonable to think of that as a decimal. Because if I were to ask you how high a ball had bounced, you would probably not respond to me, well, it bounced 343 over 10 centimeters. You'd probably respond with something more like, I'll divide that decimal point, 34.3. You'd probably say something like 34.3 centimeters, or even approximate it depending on the context of the problem. 34.3 here I can check against the book's work. Sure enough, 34.3. That is really ugly. That is much more attractive. 34.3 for our fourth bounce, and following a similar process, multiply 34.3 times 7/10, our common ratio, and you would find, I'm just going to look at the book's answer for this part, approximately 24 centimeters. And we're done. And a got it question. A reasoning question. To find the height of the 10th bounce, would you use the recursive or the explicit formula? Explain. Part B. What are the heights of the 6th and 10th bounces in an arithmetic sequence? So think back to arithmetic sequences. Recall that the middle term of any three consecutive terms is the arithmetic mean of the other two terms. The geometric mean of two positive numbers, x and y, is the square root of x times y. So consider this. In a geometric sequence, the square of the middle term of any three consecutive terms is equal to the product of the other two terms. For example, examine this sequence. 2, -6, 18, -54. So let's consider, we're assuming this is geometric, but let's make sure. Times -3, times -3, times -3. All right, so we have a common ratio of -3. 18 squared, so our middle term squared, equals the product of the term surrounding it. So the product of -6 and -54. This can be really helpful when you're attempting to find missing terms in a geometric sequence. Note that the geometric mean is positive by definition. There is only one geometric mean of 2 and 18. But the opposite of the geometric mean is also a possible value for the missing term in the geometric sequence 2, blank, 18, etc. So what that's basically saying is that in a geometric sequence, we'll consider this. 1, 4, 16, 64. Let's pretend for a moment that we don't know the value of our second and our fourth term. So the 4 and the 64 aren't there. Maybe they're hidden. We can determine the common ratio in this sequence, but keep in mind that common ratio could be 4. Right? 1 times 4 will give us 4 in this hidden value, times 4 again would give us 16. and then times 4 again would give us a positive 64. In not knowing the second term or the fourth term, we have nothing to say that our common ratio isn't negative 4. Right? It's definitely a possibility that our common ratio is negative 4. That would satisfy what we know about this sequence thus far, and that is that the first term is 1 and the third term is 16. Check it out. 1 times negative 4 would be negative 4 in this unknown value. Negative 4 times negative 4 is 16, positive 16, times negative 4 would give us a negative 64. That's what this is trying to convey, is the fact that if we have an unknown value, it's possible that that unknown value is either positive or negative in some situations. So it's a very good idea to check both the positive version of the geometric mean and the negative version of the geometric mean. So let's put the geometric mean to use in solving or in finding a possible missing value in geometric sequence. This one's multiple choice. What are the possible values of the missing term of the geometric sequence? Well, we have 48, missing term, 3, etc. So keeping in mind what we know about the geometric mean, we know that the arithmetic mean of 48 and 3 will be the square root of the product of 48 and 3, and we know that will equal x. Or it is possible that the negative version of that will equal x. So let's evaluate. 48 times 3. I know that 50 times 3 is 150. And I know that 48 is 2 less than 50. So I'll be subtracting 6 from 150 to get 144. The square root of which, positive or minus, will equal our value for x. Turns out 144 is a perfect square. The square root of 144 is 12. Therefore, positive 12, but also negative 12 are options for our second term, meaning C is the correct answer. And your got it question. The 9th and 11th terms of a geometric sequence are 45 and 80. What are possible values for the 10th term? Work carefully and make your selection from the choices below. And your lesson check for this section.